Hey pre-calc students, so today you are going to figure out how to find powers and roots of complex numbers. This is called the Moivres Theorem, and again it just says the ability to write complex numbers in polar form allows us to use a very helpful theorem. This is the theorem, and it allows us to quickly compute powers of complex numbers if we can convert them to polar form. So again, we're looking at converting a complex number, which is a plus bi, into polar form. Okay, so we're going to be writing it in polar form, and then we're going to find powers. For this particular one, we're going to find powers of a complex number. So again, for the first blank, just put in, it helps you to quickly compute powers or roots of complex numbers. And again, we're just going to practice powers today. So it's really the same thing with roots. So you can kind of see it on here, powers and roots. Basically, whatever you find, once you find theta and you find the radius, then you'll just follow this equation here, and whatever your power is, that'll represent n. You'll just fill in the n's, and then you can simplify. So for 2 plus 3i, remember this is in the first quadrant. So you're going to have to know, just like you did before, you're going to want to know where this is so that you can figure out, if you find your angle using inverse tangent, you'll know how to compute the right angle, whether you're given like a reference angle or the actual angle. So like if it's in the first quadrant, your answer is actually going to be the actual angle. So so this point is in the first quadrant. That's my son in the background. Okay, so this theta right here is the theta we're looking for. Okay, and remember we have to find theta and we have to find the radius. So just reviewing how you find theta. We did, remember, the tangent, inverse tangent of b over a. Remember, for a complex number, the first number is a, and the second number here is b. So a is 2, b is 3. So if we want to find the inverse tangent, what we'll do, find the inverse tangent of 3 over 2, because it's b over a. And when I do that, I typed in inverse tangent of 3 over 2, and I ended up getting like 56.3 degrees. So we'll use that, 56.3 degrees. Okay? We also have to find r as well. So r is found, remember, this is like the modulus. We have to take a squared plus b squared and then square root it. So this is 2 squared plus 3 squared. And remember, this is 2 squared is 4, 3 squared is 9. So 4 plus 9 is 13. So this ends up being the square root of 13, and we can't really simplify that. All right, so for the very final step here, to write your power, you just have to follow this form right here. So we're going to have, basically it's saying z is 2 plus 3i, raised to the second power. So we're going to say n equals 2, because that's the second power. And then fill this in. So we have r to the second power. So r, remember, is square root of 13. So we're going to do square root of 13 to the second power. Okay, times cosine, and then this will be 2 times our angle. Our angle, remember, is 56.3 degrees. I'll just put in here 2 times 56.3. And then we'll fill that in. We'll simplify it. Plus I sine of the same thing, 2 times 56.3 degrees. Okay? And then we just have to simplify this. Well, I know that the square root and the square ends up canceling. So really, I just have a 13 on the outside of this. And then I'll say cosine of, and then we'll do 56.3 degrees times 2. And we get about 112 degrees, or 112.6. So we're going to say 112.6. That's degrees. Okay. Plus I sine of 112.6 degrees. And there you have it. There is the answer for 2 plus 3i squared. Okay? The only difference that you're going to have with some of these other ones is, again, where the angle is. So let's look at this last one, number 6. So this one is at -8 and then down, or no, up, sorry, -8 and then up 1. So it's right here. It's in the second quadrant. So we've got this angle right here. We're looking for this one, theta. But when we put this in the calculator, it's going to give us this little sliver right here. That's a reference angle. Okay? We'll call it beta. We kind of did that last time. So we're going to find this little reference angle, and then we're going to use our idea of 180 degrees or 360 to help us solve this. So tangent, inverse tangent, right, of 1 over -8. Okay, so we're going to do that real quick. So inverse tan of 1 over -8. That gives us about 7.1 degrees. -7.1. So this is about, like I said, 7.1 degrees from here to here. Okay, so if it's 7.1 degrees, then what would that make theta? Well, we know it's close to 180. So what we do is we take 180 and we subtract the 7.1. And then that'll give us this angle, starting from 0, it'll give us this angle theta here. Okay? So, just taking this answer, so 172.9 degrees is what theta is. Okay? So now I'm ready, other than finding my radius here. Let's do that real quick. Remember, it's the square root of, and then a squared plus b squared. That's 64, because that's -8 times -8, that's 64, positive 64, and plus 1, because 1 times 1 is 1. So 64 plus 1 is 65. So that, 65, square rooted, is our radius. So now all we have to do is put it into that form, the power form, this one right here. Except in this case, n is actually equal to 4. So n equals 4 on that one. So now you have to do the square root of 65, that's the radius, to the 4th power, times cosine of, this time, again, n is 4, so it's 4 times the 172.9 degrees. It's going to be pretty big, huh? Plus I, and then sine 4 times 172.9 degrees. So we just simplify this. So if I want to simplify this raised to the 4th power, if you want to do it on your calculator, it'll be like, if I raise it to the 2nd power, that'll be 65. It'll undo that square root. And then if I square it again, that's like 65 times 65. But I'll show you on here. So square root of 65 raised to the fourth power is going to be like 65 times 65. So 4,225. So 4,225. And then we're going to say cosine of, and then we'll just have to do, again, this is a big number, but 172.9, okay, times 4 is 691.6. So 691.6 plus I sine of 691.6. So that would be your final answer there. And if you wanted to, I guess you could probably figure out what the reference angle to this would be, because 691.6 would be going around once plus almost 2 times, basically. But that's your final answer for that.